Hello dear friends, welcome to another GIS and remote sensing YouTube channel tutorials. Today we will discuss about satellite image corrections. Especially we will focus about radiometric calibrations. What is a radiometric calibration? Sometimes in many channels you should watch just the processes how to radiometric calibration is done. But in this tutorial, we will discuss how radiometric is generated, how radiometric error is generated, how we should resolve, how we should um, uh, run the radiometric calibrations. Especially, we will talk about the radiometric calibration, especially in ENVI5.6 softwares. This tutorial will include about what is a radiometric calibrations and also radiometric calibration details window and the third part is practice part. Friends, any questions, suggestions, please contact with this way. And also, if you now joining with me, don't forget to click on the subscribe button and also you could share the video with your scientific persons, and also for encourage me, don't forget to click on the like button. Okay friends, if you want to buy a tutorial by the name of glacier glacier mapping, please contact with the www.girs.ir. This is an academic, especially in GIS and remote sensing channel. My tutorial will you find in this site. Also, come to what is a radiometric corrections. Please pause the video and ask questions with yourself. What is a radiometric corrections? And also, which factor that create radiometric corrections is very important. In here, the factors that create radiometric errors is sensor or satellite errors. How? By the example, satellite 7 in 2003, it found a gap by the name of scan line. This is a radiometric errors. And also the second one is atmosphere errors. These errors are including a slope, topography, and spec. In here, now we want to ask a questions from you. What's the radiometric corrections? Radiometric errors means making errors in different properties. What's the different properties? Different properties mean spectral resolutions of satellite images. By the example, when electromagnetic reach into sensor through the process of emissions, reflections, and scattering, it can be accompanied by change in the atmospheres. When you imagine that when an electromagnetic wave come to or reach from the into sensor, this electromagnetic include that emissions, reflections, and scattering. When if you want to solve these process, you must be process the radiometric calibrations. And here I want to ask a questions. What's the radiance? Pause the video and solve the questions. In here, radiance, the amount of electromagnetic energy that reach into sensor into watt per pixels. This electromagnetic includes reflections, emissions, or scattering. Also noise produced by the sensor. Another question, what's the reflectance? The amount of electromagnetic energy that reach into sensor in the term of wave reflections. Sometimes you hear what is the top of atmospheric corrections, what is surface reflections. In here, a top of atmosphere reflections means the amount of reflections reach into sensor that is affect that is affected by atmospheric absorption and scattering process. Usually, the reflection that is calculated in the radiometric correction section is in this parameter. If you ran the radiometric corrections, you have an image by the name of top of atmosphere reflection. Top of atmosphere reflection means an image without atmospheric absorption, without scattering process. The second one is surface reflectance. Surface reflectance means the amount of reflections that reach into sensor that was emitted directly from the Earth's surface and was not affected by the atmosphere. This surface reflectance, atmosphere not affected in the wavelength. And also the reflectance is usually between 0 and 1 or 0 into 100 percentage. Another one is what is the brightness temperature? It is the brightness temperature or temperature recorded by the sensors. The brightness temperature is different from the Earth surface temperature. And here we talk about the difference. The surface temperature of the Earth refers to the temperature of the phenomena on the surface of the Earth, which is not affected by atmosphere and sensor, but brightness temperature refers to the temperature of the phenomena on the Earth on the surface on the Earth, while the atmosphere and sensor have previously affected it. Okay. Here the radiometric calibration window that you will see in the calibration type. In here we have two type. The first is radiant, the second one is reflectant. The second one is in here we mistake, not reflectant. Radiance and brightness that I have already described in last slides. Output interleaves is divided in three parts: BSQ band sequential, BIL band interleave by line, BIP band interleave by pixel. Usually BSQ is referred to should be choose at the default. Output data type is in here port divided into three port flatting pipe. Double, you know about the double precisions, which about the integer and precisions. And also this one is the 16-bit unsigned integer. Thank you. Come to practical part. Okay, this is the ENVI5.6 softwares. In here is data management tools. Click on the open. In here we have used Lancet 8. The date is 2020. You should choose MTL file. Just click on the open. It takes a minute or some second, depend on your PC ability. Okay, in here we have a more type of image: multispectral, panchromatic, cross, thermal, and quality. Okay. Now in the toolbox, click on radiometric calibration. Double click on this one. In here you should at first click on the multispectral spatial subset. In here you could choose and which part do you want to process the area, which area you want to. This area is my focus area, and in here after this we have this image just. Okay, spectral subset, which one do you want to done the radiometric calibration. In here we select all one, just okay, click on the okay. In here which calibration type, which this one is radiance reflectance, we choose radiance. Output interleave is divided three part, we use default BSQ. Output data type is the divide tripart. We use flat. Scale factor is 1. If you want to have more focus in the this radiometric calibration, you can change it in the 5. But default is 1. If you want to apply flash, if you want to, after running processing the radiometric calibrations, running the atmospheric correction, just apply flash. And here output file name, and here we use Lancet 8 save. Just click on the OK. This will take some minute, depend on your PC ability and also depend on your image size. Okay, the process is done. This is the part of image that radiometric calibrated is done. In here in the view, just click on the two vertical view. This one come to here. Okay, this should be off, and in the view, link views, link all, just okay. You see this right image is radiometric calibrated image. In here you should clearly what the different, what the pattern changes more scientific. Okay, after this tutorial we will talk about the atmospheric corrections. Just follow us. See you.